Now we're going to do an introduction to radicals and simplifying radicals. Now you might be saying, why are you doing this here? Well, because there's other ways to solve equations other than factoring. So we need to introduce this first, and then we'll talk about other ways to solve those equations that we just solved. Now, the square root of 25 is 5. Negative square root of 25, we bring the negative out because he's in front. Square root of 25 is 5. Now the square root of negative 25 is not a real number. Now you might be saying, why? Why couldn't it be negative 5? Because when you multiply the answer that you get by itself, we'll get a positive 25, not a negative one, so that can't be it. 5 can't be it either, because we'll still get a positive 25. For both of A and B, we get 5 times 5, which is 25. This one, 5 times 5 is 25, and we're negating. So whenever the negative is under an even radical, an even, because when you multiply negative numbers an even amount of times, the result becomes positive. Now let's look at D, the cube root of 8. That indicates to me that I need a number that if I multiply it by itself for a total of 3, I have to get 8, and that number is 2, because 2 times 2 times 2 equals 8. Yay! Well, what about a negative cube root? Well, turns out there is a real number, and it's negative 2, because negative 2 times negative 2 times negative 2 is negative 8, so we're psyched. And F is similar to letter B in that I negate, do the cube root of 8, and get 2. So it's the same result as E. Now let's find each root. Now we're going to assume that all the variables are non-negative. In other words, I don't have to worry about absolute value. That gets higher level. So we're going to take the square root of each one of these. Now I always think of it as this way. A pair comes out as a single in a square root. So a pair of 4s comes out as a 4 because the square root of 16 is 4, but a pair of 4s comes out as a single 4. A pair of x's comes out as a single x, and a pair of y's comes out as a single y. Now let's do this next one. If we think about it, this becomes, and you don't have to write these out, I'm just trying to give you a visual of this. I know, especially since I'm crazy and I'm writing out 8y's. There we go. Now, here's the deal, guys. Every pair comes out as a single. So you say to yourself, oh, I have 3 pairs, so x to the third. This guy comes out as x. This guy comes out as x, and so does this. So I have x times x times x, which is x to the third. A pair of 9s comes out as a 9. Now let me box the pairs of y's, and I have 4 of them. So it's y to the 4th, y times y times y times y. Done. And the radical is now gone. It's eradicated. Get it? All right. How about the cube root? That means every triple comes out as a single. So every triple. So what we're doing here is 27, 3 times 3 times 3, cool. X times x times x, cool. Oh, there's 15 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now I'm not going to write these. I did write them all out just so that you have a visual. So a triple comes out as a single. A triple comes out as a single. Now, how many triples do we have here? And you're saying, well, can't we just divide 15 by 3 to get the number of triples? And you would be right. So we're going to get 5 triples. Done. Now we have a fifth root. That means any group of 5 comes out as a single. So we have 5 x's, so they come out as a single. We have 15 y's, which means we're going to get 3 groups of 5, so it's going to be y to the third. Now, if you have to write this out and group them in 5s, you go for it. Okay, now we're going to do simplifying radicals. And that means I don't want to have any perfect squares or perfect, well, I don't want to say perfect cubes, but a group of 3 under the radical if it's a cube root. But now we're just looking at square roots, so we're like psyched. All right, so what I would like to do is take out any perfect squares and put it in front. So 40 is really, if I go over here, it's 4 times 10. 4 breaks down as 2 times 2. So I did, what is this called? Do you remember? It's called prime factorization. So when I put that in, and what do you tell me about square roots? Every pair comes out as a single. And inside I have no more pairs, so I'm just going to multiply those together, and I get 10. So it's 2 times the square root of 10. Cool? How about y to the 9th? Remember, every pair, 1, 2, 3, 4, 5, 6, 7, 8, 9, these are all multiplied together. Every pair comes out as a single. Well, how many pairs do I have? Well, I have 4 pairs, and they're out of there. But I have a little lonely guy left inside. He can't get out unless he has a partner. Let's do the next one. Well, 44, if I think about it, over here, if I break her down, 4 times 11, so 2 times 2 times 11, and then I have 11 x's, which I can write out. Each pair comes out as a single guy. Good? How many pairs can I pull out of there? Well, I can pull out 5 pairs of socks, and I'm left with 1 sock inside, 11x. If you don't see it, write it out. So I have 1, 2, 3, 4, 5 pairs. They come out of there inside, yeah, 1x left. Let's do the next one. Well, this one is kind of nice because the square root of 9 is 3. How many pairs of x's can I pull out? 5. There's nobody left inside. 49. 7. Y to the how many pairs? 3. I always think of this as socks. I know it sounds crazy, but it helps me. How many pairs of socks do I have? I pull out the pairs. Now let's look at cube roots. Again, we're thinking of triples that come out as singles. So let's do the triple-y thingy-wingy. For 24, we can do 2 times 12, 2 times 6, 2 times 3. The prime factorization of this looks like 2 times 2 times 2 times 3. And then I'm going to write out those x's, and then I'm going to write out the y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so let's do the triple-y things. Comes out as a 2. Comes out as 1x. And now how many triples can I get out of these guys? Well, 1, 2, 3, 4, 5. 5 triples. Now we have to be careful about that. That's a cube root. What's left over? A 3, an x, and a y squared. So for me, I think of, well, how many triples can I get out of 17? 17 divided by 3 is 5 triples with 2 left over. Yeah. Let's do the next one. Let's see if we can do it without triple-y whipply. So how many triples can I get out? 3 triples is 9, right? So inside here, I have a cube root left over of y squared. And you're like, you're breaking it up. You can. It's a rule for division. You can break them up individual radicals, and then in the end, I'll make it look pretty. Okay? Cube root of 8, 2 times 2 times 2, bring it out as a 2. And I am left with triple of x's, comes out as an x. I don't have anything left underneath. So to make it look pretty, you can write it like this. Nice, beautiful, or like this. Either way is good. Now you are able to do the homework assignment for this lesson. And be sure to ask your instructors lots of questions if you have issues. But my recommendation to you is if you don't see it, write it out and circle either the pairs you need or the triples you need or the 5s or the 4s. Go for it.